different fish. Okay, weight of different fish. Okay, you must include all possible invariants in the fish farm state space. Okay, so let's put the state space schema. So our schema name is fish farm. So the first variable, which is the fish, this is using the bag. So we declare as a bag fish. Okay, then the second one is the food, which is showing the connection between the fish. What was it? Food. Okay, so we can have many to many, so we can use the binary relation. Okay, and then we can have the weight, which is showing the weight is the average weight of different fish. Okay, this is referring to the fish also, the weight. Okay, then our predicate here will be this fish, this fish, and this fish. So what we need to use for the average weight of fish, of different fish, what we are using, do we have any special symbols, anything which I have missed out to show the average? Do I missed out anything? It show describe the average weight of different fish. What does that mean? It's not just presenting the fish, right? It's presenting the average weight of fish. So what we need, is it like we need to store it as a natural number for the weight? Anyone? Any idea what I have missed out there? So it means we are storing it like fish, and then uh, the natural number. Is it like this? Are we storing it like the fish, and then what is the natural number I mean the weight in a natural number? Is it supposed should be like this? Okay, that's why, because fish means like nothing. Okay, so now the connection. So we have domain weight, uh, maybe domain food, and then this one is what we are referring to, the bag of fish. So is it just fish or is it domain fish? Okay, it's supposed should be domain fish, because we are referring to the bag of the fish. Okay, domain fish. Okay, then what else we can check? uh, Can we indicate another one where the weight, this one, the range weight, it cannot be zero, so we put something like this, must be more than zero. Okay, then question B, design a schema called add new fish. So we have operation where a new species of fish will be added into the system. All the information about the new fish needed to be added. Okay, add new fish. So it's a normal operation going to cause changes to the what just now, fish farm. Okay, fish farm state space. Then what we have, okay, so we need to have three variables, I mean three input to add for the fish, for the food, and also the weight. Okay, so um how can we have new fish, so can I use the word new fish as the input? So this is presenting the backfish. Okay, then we have the new food, which is presenting the food. Then we have new weight, which is presenting the, oh, in this case, right, do we need to use n or n1? See, nobody say. Suppose should be n1, right? Okay, so here will be, because we already indicate, huh? Okay, so what should be the predicate to check? The first thing is it's not a sub. Okay, so how you will show that it's not a sub bag of fish? What is the symbol you use for not? For not a sub. Which symbol we use? Using this one, the not. How you use? What symbol? Not a sub back. Are you sure that's the symbol? Is it not this one? Is it that one? Are we referring to the same symbol here? Oh, are you sure? Why my symbol look? Oh, okay. Okay, got it. Sorry. Okay. Okay, so we use the not, okay, not new fish, okay. This must not be sub back of the fish. So what symbol to show it's not a sub back? We have a special symbol for that, right? This one. This is a sub bag. So when we use this one, it is not a sub bag of the fish. Okay, since it is a bag, so we cannot just check as using the normal element or not element. Okay, that one is set. So when we are using for checking the bag, so we use this one to present the sub bag. And when we say that it is not a sub bag, then we use the keyword of not in the front. Okay, so it is not a sub bag, so that we can add the new fish. Then after that, we need to check the food. Am I right? The food must not be uh, exist yet. This one is a normal connection, so we can directly check that the new fish and the new food must not be element of. So we can directly put the domain. Sorry, the domain new fish maplet to the new food. This is domain. Okay, must not be element of the food. Okay, then do we need to check for the weight? Can the weight be unique to check here? No need to check, only the fish and also the food. Now we can do the operation where we need to add the fish, I mean the new fish. What we use for the bag to add means, can we use the union here, or we need to use the bag union here? Since it's a bag, we cannot use union. Okay, we need to use bag union. So can you see we have this bag and then we have the plus. Okay, then okay, we add the new fish. So after that, the what is that, the food. This one is a connection normal set, so we can use the union. So the domain new fish, then the maplet of the new food. Okay, then we need to add the weight for the fish. The same thing, this one also we can use the normal union. Then we have the domain fish, maplet the weight. Okay, guys, if we use n here, then we need this. If we use n1, then we don't need this. If we use n1, then we don't need this. Nobody realized that. Okay, because n1 is already indicating that it starts from 1, it cannot be 0. So either one, you want to use n can, but just have the predicate that it must be more than 0. But if you use n1, then we don't need that. Okay, so we have add the new fish. So let's assume if we use if we want to use the n, if we don't want to use the n1, then you have to make sure that the weight must be more than 0 inside the predicate. So as part of the predicate, you need to mention that the new weight must be more than 0, then it will be added here. Okay, so if I use n1, then we don't need that. Okay, so that should be for add new fish. So we have the new fish, the new food, and then the new weight. Okay, so I use the n1. So here we check that the new fish is not sub bag of the bag fish. Okay, then we check that this not exist. So if you want to use the curly braces also can. Okay, that it must not be element of the food, then we will do the operation to add the fish. So since it's a bag, we use the union bag, and then the other two we use the normal union. Okay, got it. Okay, the next question: design a schema called update weight to change the weight of one species due to wrongly entered previously. Other information will remain unchanged. So it means we want to override the weight for the fish, but other things will remain the same. Okay, so let's put the schema. Okay, so it's going to cause changes. So this is not new fish, right? Because this one we want to add the new fish, so I give this. So what we can use here for fish, so that we can differentiate. Can I just use? Are we going to use the food? Okay, let's put. Okay, then we have what? The weight. We will use the n1. Okay, so this F is for the fish, and then this W is for the weight. So my weight is in N1. So what the first thing we need to check? The fish should be, is the fish should be inside the bag. So we can actually use this symbol, okay, that it is, um, sorry, what is this? What is this symbol? Is in back, okay, or you can also use the word, you know, right, that you can also use the word that this fish, you can use the word, okay, but since we have the symbol, we can use the symbol, okay, so it's just same meaning like that. Okay, so the fish must be in the back of the fish, okay, and then what we need, fish must be domain, which one? Okay, fish must be domain of weight. Do we need to check that? That it means we want to prove that the fish is already have a weight, is it? It means the fish is already have a weight so that we can update it. Okay, so this fish is an element of the domain weight, right? Did I use weight just now? Mm. Okay. Do we need to check that the weight are not same? Do we need to check anything like that? It means the current weight and the new weight are not the same. So it means the weight, let me put the bracket for the fish, not equal to the new weight. Do we need this? So that it will not be the same one going to be override, correct? So if they have entered 0.5 and now suppose should be something else than the 0.5. So it must not be equal. Or if you want to put the input on the front also can. So it means the weight is not equal to the weight like this. Okay. So done. So what happened? The operation here. What we are overriding? We are overriding only the weight. So the others will remain the same. So overriding means we use this symbol and then we have the fish and we have the new weight. Okay, so the fish will remain unchanged. What is another one? Weight, fish, food. Okay, thank you. Okay, so it's a remain unchanged. Okay, got it? Can understand? So this is the state space schema, fish farm, and then we have the add new fish operation, and then we update the weight of the fish while the other parts they are remain unchanged. Okay, Dana, can we move to question 2?
还这个题目呢？还有一种呢？
Okay, I believe done. Okay, so question 2. Trophy Medal Sundrian Berhad, which has been operating for more than 15 years, provide an extensive range of award trophies, medals, and plaques. Their products, either ready-made or custom-made, are distributed locally to all states in Malaysia. Recently, they decided to upgrade their sales and inventory system into the online mode in order to ease their products purchase process. You have been asked to model the online sales and inventory system that will record the operation related to the purchasing of the product. Suppose you are given, so we have basic type, which is the product, the set of all products in the shop. Then we have two categories, which is one is sorry, three types. One is the category, award, trophy, all this. And then we have another one more free type, which is the design, which is the ready-made, and then custom-made. Miss Azu can really come up with stories. Don't be surprised, huh? In your final exam, she will come up with a very long stories for you to come up with the schema. I even get to know about how to play what is that, Pokemon, through her scenario, because she come up a really detailed scenario of how to play Pokemon and then to come up with the schema. So don't be surprised with her stories. Huh? Get ready to read a long one. Okay, so question A, construct a state space schema called trophy medal that specify the following properties of the system. So the multi-set of all product in the shop, multi-set means bag, huh? Then the category of each product in the shop, the design of each product in the shop. So these two is the free type just now. The price of each product in the shop. So it means each product will have the price. Okay. So you must show all possible invariants of your properties in the predicate part. Okay, so let's put the schema. Schema name is trophy medal. So the first thing is we have the product, which is using the multi-set, which is the bag. Okay, then we have the category where each product has the category. Okay, then we have design. Sorry, where each product has the design. Okay, then we have price. Each product will have the price. Can the price zero? Can the price zero, or it should be n1? N or n1? N1. Huh? Okay. So we have the product, we have the category, we have the design, and then we have the price. Okay, so now all this product. So we have the uh, domain price equal to domain design equal to domain category equal to domain product. Okay, so all the domain. Huh? Okay, got it. Okay, the next one, design a schema called restock that will allow a staff to restock a product where this product was recently shown as low stock in the system. Okay, so it means due to the low stock, so we want to add the product. Okay, so our schema name is restock. Okay, restock. So it's going to cause changes to the record. Trophy medal. So we want to restock a product. Huh? So let's assume I use new stock. Okay, so this new stock should be a bag of product, huh? Because stock, many, multi-set. Okay, only one, only stock. Okay, so the first thing we need to check is what we need to check. What we need to check here, sub bag of the product. So new stock must be a sub bag of product. Right. Okay. Anything else we need to check? No, only one. So after that, we will add into the product. So what we use? Are we using the union? Bag union, huh? Okay. So we use the bag union to add the new stock. Okay. So what happened to others? Any changes to the category? No, all others remain unchanged. So you just put it's remain unchanged. Oh, another one who is what? Life. Okay. Okay. So that is for restock. Okay. The next one, design a schema called total product that will display the total quantity of a product in the system. Okay, so this one just to display out. Huh? Okay, so we have schema name total product. So it will not cause any changes. So we use the C trophy medal. So now we want to display the total quantity of a product. So first, what we need to know, total quantity. We need uh, total quantity of a product. So we need a new, not new product. We need to know if the product is exists first, right? It is in the product bag. So what I can use? Maybe I can use stock. Just now it was a new stock, right? So this one is stock. Okay, so this stock will be the product, and then we need output to display the quantity. So can I just put total, and this total will be using natural. Can the total be zero? Can the total quantity be in zero? Can, so we use n instead of n1. Okay, so now the first thing is we want to make sure that this stock is this one is in the product first. Okay, so once we check, then how we can get the output to get the quantity? How we can get the product quantity? Yes. Okay, so we call the product and then the hashtag of the stock. Okay, so nothing else happened, so the others all will remain unchanged. Okay, okay, so That's it
Oh,
for
okay.
our tutorial 13.
Okay, now kita lanjut. Hmm, 我没有开始。
Okay, got it? Everyone got the answers?
好了，可以了。
Okay, so that should be the two questions about the bag and also how we can do the operation schema using the bag and then using the union bag, okay, and so on. Okay, so I think that's it for our tutorial today. So I will see you on Thursday. I think we left with another one more tutorial only, yeah. Wow, so fast, huh? But we have another 2 more weeks to go, correct? Okay. Yeah, once we're done, then the following 2 weeks I will be busy with marking and we can cancel it. But I will confirmly completed everything first. Then only. Okay. So make sure come, huh? Okay. So I'll see you on Thursday, guys. Okay. Thank you very much.